Hello and welcome to this tutorial. My name is Kevin from Logimus, the Australian and New Zealand distributor of Vicon Motion Capture technology. In this tutorial, you will learn how to retarget a custom character inside of Shogun Post, use this retarget in Shogun Live, and finally stream the retarget from Shogun Live into Unreal Engine. It is typical for visual effects studios to have a dedicated real-time Shogun Capture PC that streams into a dedicated Unreal Engine PC. In this example, I'm going to mimic the studio setup by streaming from my laptop into a desktop. The only prerequisite for streaming from Shogun to Unreal is having installed the Shogun Live Link plugin for Unreal Engine. The plugin can be downloaded from Vicon's website. For the Shogun Post retarget, you will need to capture a file from the performer you're wishing to apply the retarget to. Typically, this is a ROM captured during the subject calibration. However, it can be any capture file that you use on this character. In this example, I will be using a ROM. So once you have calibrated your subject inside of Shogun Live, you will want to bring it into Shogun Post to do the retarget. So I have Shogun Post open here with a blank scene, and I'm going to show you a manual retargeting method for character retargets inside of Shogun Post. Vicon has some automatic processes. However, I want to show you the fundamentals of what goes into those automatic processes. To start, I'm going to import a ROM of Amanda. To do so, I'm just going to bring in the MCP and the X2D files and drag into the scene, and click yes to reprocessing the MCP. You do not have to do automatic reprocessing if you want to manually clean up the data. However, for this example, I'm just going to go through the automatic reprocessing. The processing time will depend on the length of the take, the complexity of the take, and the hardware that you are running on. Now that I've finished processing, I can check the range of motion that I will be retargeting to. First, I'm going to open the subject setup panel and the selection panel. This is the ROM of Amanda. We only have one subject in the scene, as you can see here and in here. Under the Amanda subject, we can see her labeling setup and her solving setup. In the subject setup panel, I'm going to select the retargeting setup. I'm going to click the load retarget or setup file and import a custom XPX. In this case, the monster character. We've imported our monster character. If you do not see this monster character, you can go through your view filters into the retarget section and uncheck the bones and the skin to see the skin, and even x-ray the skin to see the character without an x-ray on the skin. The skins live in the common Vicon folder. If you go to General and Preferences and go to Directories, you can have a look where items are stored. In this case, for the skin, it'll be stored in Users Public Documents Vicon Skins. I can open this folder and copy across the same FBX. Now that I've got my skin and my FBX inside the scene, I want to make one adjustment before setting up the retarget. In our Sections panel under Amanda, we now have a retarget section. If I hold shift and click on the arrow, it will open up the entire hierarchy. If you notice at the top of the hierarchy here, the skeletal hierarchy attached here and the skin components here. Now for the retarget, we want the root of the skeletal hierarchy to be the root joint of the retarget. During the import, it imported the monster character as the root joint of the retarget. So we're going to fix that. Under the objects panel, we are going to select unparent option when selecting the monster character, which will unparent the monster character from the retarget. And then we are going to select the monster pelvis and unparent that from monster character, and then hold control, click, and parent it to the retarget. So now we have the retargeting setup file with our pelvis bone as the root joint. You can leave the skin outside of the retargeting setup. So in the subject setup panel, we are going to go to map mode, which is going to put us into a mode where we can align skeletons for the retarget. It's sometimes referred to as a pose node inside of other VFX softwares. Notice that it has put our pose node facing the opposite way to our Vicon solve, so we will fix that. And we want to align the skeletons to be matching in position and height. We could use some of the auto set parts and skeletal setup options inside of the retargeting panel, although for the manual method, I will show you how to do it manually. First, we're going to select the retargeting setup in our selection panel, and we're going to go to our manipulator here and go to the translate manipulator. You can also get to this by pressing T on the keyboard when selecting this panel. If the manipulator size is too small, you can also press plus or minus on the number pad keyboard to scale it up or down. Now I'm going to position the character in a similar stance to our Vicon solve. If you want to get really precise with the feet positioning, go from perspective mode to front mode, and you can align the feet up nicely. I will then rotate the character around. easiest way to do this is by selecting the attributes and channels, and then selecting the rotate manipulator and rotating the z-axis by 180 degrees to be facing the correct direction. Selecting the retarget again and going back to our translator by pressing T or R for rotation, T, and we can go and adjust the hips and the feet to be in a position similar to the character. I'm just moving it backwards a bit so the shoulders are in a similar position to our performer's shoulders. Once we have moved this to that position, we can set the target scale. I'm going to select our pelvis or our character, and I'm going to scale the retarget. As you can see there, it's scaling it down. I'm going to go to about 8.7 as we are a similar height to our performer now, and then readjust the retarget with the translation tool to align the two skeletons to be a similar height and match their feet position on the ground. As you can see, now our two characters are a similar height. Now I want to position the custom character to be in a similar pose to our Vicon solve. To do so, I'm just going to grab our manipulators and adjust the positioning of the arms to match. I will speed this bit up, but essentially what I'm doing is trying to align this character so the hands and arms are facing out in that T-pose with the fingers splayed and flat. So now I have adjusted the feet positioning and the hand positioning to be very similar to our Vicon solve on our custom character. So now we're going to create the constraints. There are two types of constraints, a position constraint and a rotation constraint. The position constraint will try to match the translation as best as possible of a specific joint. For example, if I grab the hips of our solving skeleton and hold control click on the hips of our monster skeleton, if I add a position constraint, you can see this by the square, it will try to match the translation of our monster pelvis bone with our solving skeleton pelvis bone. The typical positions that you would want a position constraint in is the hips, to keep the hips of the characters in a similar position, the feet to match the feet when placing them on the ground, the head and the hands. The hands and the head are dependent on your character, as sometimes just the rotation is okay. We're going to grab the foot base and the foot base and create a position constraint. So we have a position for the pelvis and now the feet. As you can see here, I have mirror creation on, which is why I created it for the left and right. So this constraint is between this toe base and our monster's toe base. And we could do the same for the head here for position and the hands. But for this demonstration, I'm just going to go through the rotation. I will select the pelvis of the monster character and the pelvis of the solving skeleton by pressing Control and clicking them both and adding a rotation. As you can see here, we have the rotation constraint. This hip is going to control the rotation of our monster's hip. And we're going to work our way up the spine and do all the joints on the spine. So we have this one here, spine 1, this rotation here, which is spine 2. For this example, because these spine joints are much bigger and there's less of them than the solving skeleton, I'm going to use this one as a rotation as well. This root joint is being driven by these two bones here with a weight of 50-50. And we're going to work our way up. So this spine 3 is going to rotate this one, and we're going to go onto the neck, rotate, rotate. And because this is the head, I'm going to use this spine to rotate these two. So this spine joint is controlling these two on the custom character, and our head joint is going to control the head joint, and the rest of them we can leave. Now we're going to work on the arms. So we have our clavicles, and we're going to work our way down the arm. So if you notice, the monster arm is much longer than the solving skeleton. We're going to use this bone to drive the two bones. So we're going to drive this one with a rotation and this one with a rotation. So we're mimicking this bone being two bones instead. And we're going to do the same with the forearm, add rotation, add rotation. And so that is the custom character's arm. As you can see, it's going to do the same thing on the other side because we've got the mirror creation on. And now for the hand, because we have this other hand bit here, we're going to pilot it with this, just the hand joint, add a rotation here. If you wanted the positions to be exactly the same, you would start to put a a position constraint as well. Although because the arms are much longer, we are not going to do that, because as Amanda's hands get closer to her body, the longer character will come in more and cause more clipping. All these bones here, we don't need driven by the rest of the metatarsals. We can just drive them from the center one, so the hand stays relatively flat. So I'm going to add rotations to all of these in the middle hand section there. So this joint on our solving skeleton is piloting all of these. Then we're going to work our way down the fingers. So I'm going to select thumb and work our way down. Add rotation here, add rotation here, add rotation at the end, and there. And we do the same for the ring finger, rotation, rotation, and the end one, rotation. And you can see that I'm making these constraints. If you do not see those, you can select the constraints on the retargeting view filters. The same for each of the fingers. I'm just going to go through this really quick. Okay, so I've retargeted the 5 fingers to the first 5 fingers of our monster character, but if you've noticed, he has 6 fingers on his character setup. So what we're going to do is drive the extra pinky finger with our pinky finger, so these 2 fingers will be controlled by this finger. So as the pinky moves, it'll move in tandem with this one. Grab. So even non-human characters you can retarget. Okay. So now I've added all the rotation constraints to the hand, and it has automatically mirrored the creation. If it hasn't, you might have to go and manually do it on each side. Now I'm going to work down to the legs. The same idea with the legs is this long bone is going to drive these 2 shorter bones. So we're going to add a rotation, add another rotation, and do the same for this shin bone, add rotation, add another rotation, and then the base, add a rotation, and we don't need pilot toes. The last thing we need to do is set the weighting. So for the position, you can leave the positions at 1, and the rotation you can select by holding Shift Select and double click and change the value to 200. The number is a bit arbitrary, but you want more weighting on the rotation than you want on the position, because the position is a stronger, more aggressive constraint. There is one step we may have missed, and that is the degrees of freedom on individual bones. So let's just go to our view filters and turn off our constraints for now. What a degree of freedom does is it allows for certain degrees of rotation on each joint. Where this becomes useful is if you think of a elbow or something as a hinge joint, it can only bend in one direction, and we don't want it to rotate this way, but we may want it to just rotate that way. So we can disable and enable degrees of freedom by going to our attributes tab and enabling certain degrees of freedom. So we can remove our degrees of freedom on our elbows and our knees in particular. For this example, I'm just going to leave everything without the degrees of freedom checked and see how it retargets. So now we have done the manual retargeting, it's time to save it out. We go to our save options here and just press save. Monster retarget demo. Now I've saved out that retarget. Let's exit map mode and test the retarget. There are 3 options up here for our retargeting. We can retarget a single frame, we can retarget over the entire play range, or we can retarget over selected ranges. I'm just going to retarget this single frame, and so we can see our retarget in action here. We can also turn on interactive retargeting, meaning every time we adjust a frame, Shogun will retarget that specific frame. If I turn it off, you will see it's only retargeting those specific frames. I'm going to retarget over the entire play range and then view the animation. This retargeting process could take a little bit of time depending on your hardware and the amount of retargeting that you are doing. So now that retargeting is done, we can scrub through the play range to see how our retarget is performing. Now that I'm happy with my retarget, I'm going to save our project as retarget. Now there's one final optimization thing you can do for the live capture. Once you're finished and you're happy with your retarget, you can delete any unused bones to help the processing in the real-time setup. So if I go to X-ray, we are piloting all of the bones with the constraints on them. So as you can see here, we're not using any of the tail bones, and we're not using any of the face bones here. So what I can do is delete out the unused bones to use in live, so we're not driving any bones that we're not planning on using. So now that I've saved out our retarget demo, I'm going to delete the bones and save out another retarget as deleted bones. What I'm going to do is go through our retarget and select any of the bones that we are not using. I'm not using any of the jaw bones, so I can delete these. I'm not using any of the tail bones, so I can delete these. I'm not using any of these toe bones, so I'm going to delete these. And the same on the other side. So now I have a retarget file with only the bones that are piloted, so I can save this out as a VSR with the same thing but deleted bones. VSR, and I will save out this scene with deleted bones. One thing you need to be aware of this process of deleting the bones is if you were to now export this retarget as an FBX to use inside of Unreal Engine as an animation take, it will not register inside of Unreal as the same character. So if you are using this as a post workflow to export and import directly into Unreal as an animation take, you will need to have the character with all the bones attached. We are back inside Shogun Live now. If you had a volume in front of you with people in it, you would set up the system and put your performer that you just set up the retarget into the volume. In this case, I'm using my laptop with no Vicon system attached. So what I'm going to do instead is use Vicon Virtual System to stream pre-recorded data so that your computer thinks that a Vicon system is attached. I'm going to stream the X2D file called Screen Queensland Demo Monsters Take 2, a demonstration video we did at Screen Queensland. I'm going to open this X2D inside of the Vicon Virtual System. I need to set the system up. As you can see, our cameras are calibrated in a specific volume, and we have our subjects in the tracking tab. If you have just opened this up on your laptop that was never connected to the system when it recorded this data, it won't understand where these cameras are or what is in the tracking tab. So we need to load them in. To do so, you just load the MCP file of the same take into the calibration tab and into the tracking tab, which will load all the characters. For this demo, I'm just interested in Amanda, so I'm going to disable our other actors, and I'm going to open up Vicon Virtual System and run that X2D to stream the data. As you can see, it is now emulating a live setup, and we can set up our retarget onto Amanda. I'm going to go into our solve setup here and click on X-ray so that we can see Amanda in an X-ray. I'm going to select Amanda under properties. We can see the retarget is missing. There is no retarget set up for Amanda at the moment. We can go to the retarget section and load the retarget that we just made inside of Shogun Post. If it doesn't appear in this list, then we can go to our settings and preferences, user, and find the project files where the retarget should be living in. It is here, and we can open up this folder and save our retargets into this location. By default, Shogun Post will automatically save these retargets into this location. So I'm going to select the Amanda retarget demo, deleted bones, and under the view filters, I'm going to go to our retarget and go to X-ray. And we'll put on the solving skills component as well, so we can see how well the retarget came across. And as you can see, we have a real-time setup with our retargeting bones. I'm just going to exit out of X-ray mode, and so we can see how well the retarget is coming through in real time. So now let's move over to Unreal. You will need to have downloaded the Live Link plugin for Vicon and then enable it in the plugins menu, Vicon Data Stream Live Link. If you cannot see this, then you need to install it and download from the website. Once you have downloaded the Live Link plugin, you need to create a Live Link source from the IP address of the PC that you are receiving data from. Find the IP address on the computer that you are running the Vicon system on by going to command prompt and typing in ipconfig. You will find your IPv4 address. Copy this and under source, Vicon data stream, put in this IPv4 address in the server title. Enter your support number. For character animation, use support 801 by default. As you can see, we have stream coming in from the Vicon system. On the Vicon system, I only have Amanda enabled, so we are only seeing Amanda in the Live Link panel. So to set up this character, let's navigate to the characters tab. So what you can see here is we have our character skeletal mesh, which I have previously imported. So let's create a new blueprint character. Let's call it an actor and call this BP monster test. In this blueprint, we are going to create a new skeletal mesh and select our monster. As we can see, we have our monster's skeletal mesh here. Then we're going to add another component, make this a live link skeletal animator, and set this to auto activate. Under the mesh settings, we are going to use our blueprint animation class and create an animation blueprint for it. But first we'll compile and save this. So I'm going to minimize this. I'm going to create a new animation blueprint for this skeleton, the monster skeleton, and call this ABP monster test. And in this animation blueprint, we are going to select live link, pose node, select our Amanda animation and link the results, file, save, and we should see the animation coming through in real time. You'll see a note here to get rid of this. We will make a local space reference pose node, and we will link that to the input, file, save, and you'll see the note goes away. You press Q to align the pose nodes, make it nice and neat. Save. We're going to go back to our original blueprint that we made with the skeletal mesh, and we're going to select our animation blueprint monster test, which then will play in real time, as you can see. And we're going to file save that, and we're going to minimize this. Now we can drag in our blueprint for our monster test into the scene. As you can see, this is quite small because the monster we have up here is 30 times the scale. So we're going to lock the scale here and increase it by 30 times. And now we have our animation playing in the editor in real time. As you can see here, we have our retarget streaming in real time. One additional thing we can do for optimization on our skeleton is go to the monster skeleton and show the retargeting options. Leave the root joint, the pelvis bone, as animation. By default, they will all be animation, and select the rest of them and set the reclusive translation retargeting to skeleton on the rest of the skeletal hierarchy. This will match the retarget seen in Shogun Post or Shogun Live 1-to-1. So now we can see we have successfully created a retarget in real time. Hope you found this tutorial useful. Thank you so much for watching. See you in the next one.